Okay, and here we are. So I just want to wrap up this problem as we move on next pieces. It says find the velocity at time t. What did you come up with for the derivative? Negative 4t squared plus 20t plus 12 all over t squared plus 3 quantity squared. So what we ended up with is we wanted to find when the particle was changing direction. And remember, we came up with a graph that looks something like this. So v of t, the derivative, looks something like this. Okay? And we saw that it crossed the x-axis at that spot. That's when the particle was at rest. It's when it changed direction. At what time was that? 5.541. Okay? So when we try to find the entire distance that the object traveled, or that the particle traveled, we needed to take into account the position. This never gets old. Never gets old. I'm wondering if I could get in trouble with that. You know what I mean? Having it on YouTube. Do you think that would cause an issue having that on YouTube? Think somebody would report. We're gonna find out. Okay, so this is definitely not promoting guns, right? This is saying that maybe it's just saying don't be Sam. Maybe it's not saying right. It's okay. Obviously, a very confusing message. Okay, so I have the two functions here. Notice in the first one, I have 4x minus 10 over x squared plus 3. And the second one, I have the velocity function. So what I do is as I go to the table here, I check this out, and you see that we have these three guys that are sitting here. I need to be able to figure out the kind of the motion of this particle. So I'm going to draw a diagram that shows this motion. And I try to figure out where it is at time 0, where it is at time 5.541, and where it is at time 8. Because it says find the entire distance traveled. I find the beginning, I find the end, and I find wherever it changed direction. Now, if you guys notice in your worksheet, problem number 2, it changed direction twice, right? I think it changed at 1 and at 5. So therefore, you need to check both of those. As we plug it in, I go into my x equals, and I type in 0. I type in 5.541, and I type in 8. And when I do that, I get those values. Am I looking now at y1 or y2 in this situation? Why am I looking at y1? Because that's its location, right? That's its position. So here's what I have. The particle starts at negative 3.333. I always like to put 0 on there. It helps me with a frame of reference. It travels over to 0.328. Then it travels to 0.36. Well, I'm sorry. I mixed those up, didn't I? Thank you. Everybody makes mistakes. Travels to 0.361 and then travels to 0.328. Particle starts here. As you notice from our graph, is the particle traveling to the right or the left at this time? It's traveling to the right because the velocity is positive. The function is sitting above the x-axis. So it's traveling to the right. Then when it gets to 0.54 or 5.541, that's when it crosses over. It starts traveling to the left because it's below the x-axis. That means that the velocity is negative, so it's traveling to the left. So that's the motion of the particle. So I want to figure out the entire distance. So the distance from negative 3.333 to 0 is 3.333. What do I add on to that? 0.361, and I add on to that whatever the distance from 0.361 to 0.328 is. So 0.361 minus 0.328, whatever that comes out to be. go to my calculator. You might look at this and say, Mr. Gens, this is ridiculous. These type of numbers, we're not going to encounter this. Actually, this is pretty close to what you're going to see on the AP exam. So learning to work with these kind of weird decimal situations and these strange looking graphs where you have to zoom in, this is not uncommon at all. I got 3.727. And on the AP exam, they do go to 3 decimal places. So 3.727 feet. And that's the answer. Question. Okay, example here, and then we're going to take a break, let you work for a little bit, okay? A ball is thrown upward in the air. Initial velocity of 18 meters per second. The height of the ball is modeled by this equation. What shape does that make? A parabola, right? Is it up or upside down? Upside down, correct? Because it's negative 4.9 t squared. So the question is, what is the maximum height that the ball reached? What do we call that spot on the vertex? Oh, I'm sorry. What do we call that spot on the parabola? The vertex, right? And we do negative b divided by 2a. Remember that, right? No more, folks. No more. We want to find the maximum height of the ball. What do you notice about the derivative at the maximum height? 0. So you want to find the maximum height of it. Just take the derivative and set it equal to 0. What's the derivative of 18t minus 4.9t squared? You don't have to use the algebra. You just take the derivative. So 9.8t is equal to 18. Divide by 9.8, what do you get? So the maximum height of the ball, it happens at 1.837 seconds. But it doesn't ask when it happens, it asks what is the maximum height. What would I then do with the 1.837? Plug it in where? H of t, right? $18 times 1.837 minus 4.9 times 1.837 squared. 16.53 feet. We good? What is the height of the ball after 2 seconds? How would I determine the height of the ball after 2 seconds? Plug it in there. H of 2 is 18 times 2 minus 4.9 times 2 squared. 16.4. Can you tell me if it's on its way up or way down after that? It's on its way down, right? So it makes sense, 16.4 and 16.53, it's on its way down. The 2 is after the 1.837. I want to figure out the velocity of the ball after 2 seconds. Should the velocity be positive or negative at 2 seconds? Should be negative, it's on its way down, right? How do I determine the velocity after 2? 18 minus 9.8 times 2. Very good. Let's figure out what that is. 18 minus 9.8 times 2. Negative 1.6 feet per second. Oh, looks like we're in meters, huh? Sorry about that. We're going to switch this last question. What is the velocity of the ball when it has a height of 1 meter? Turn and talk to somebody. How would you begin figuring that out? Take 30 seconds. How would you begin to figure it out? Go. Okay. Okay, well, what do you got? What do you do first? Close. We want to know when the height is equal to 1, correct? First, we need to figure out at what time is it equal to 1. So 1 equals 18t minus 4.9 t squared. Or 0 equals negative 4.9 t squared plus 18t minus 1. Can somebody please use the quadratic formula on their calculator to figure out at what time that happens? We got 0.056 and 0.362 seconds. Does it make sense that the ball would have a height of 1 twice on its way up and on its way down, correct? So the question is, though, what is the velocity? How would I determine the velocity? Plug those back in to the velocity function. So I have 18 minus 9.8 times 0.056. I get 17.45 meters per second. And if I do the 3.62, I should end up with a negative because it's on its way down, 3.62. And I get negative 17.48 meters per second. Okay, anybody taking econ right now? Yeah, any econ people? Yeah, we got one. Cool. All right, 2 people taking econ. Flip it over, look at this part. Yep. So this is the last part. This is pretty easy, but it's a good transfer to where you're going. So Cully made a really good question earlier, asked a really good question. He said, when are we going to use this in real life? Economists use calculus all the time. In fact, if you decide you want to be an econ major in college, they might have you take calc for econ majors. So it'll show you some of the applications, which is pretty cool. But we're gonna build some girls. Who's got the most shoes here? If I go into your closet, who's got the most shoes? Who do you think? Sid, how many you got? All right, we need a number here. That's not that many. Okay, all right. Bailey loves her shoes. She got like 30 pairs of shoes, right? Bailey's gonna make her own shoe factory. Now you tell me this. Tell me this, okay? You have to think about this. This is where people get confused, okay? Is it gonna cost Bailey more to make 1 shoe or to make 100 shoes? 100 shoes, right? Like she's going to have to buy supplies to make 100 shoes. Now, is she going to be more efficient if she makes 1 shoe or 100 shoes? 100, right? So, what will cost more, producing the first shoe or producing the 100th shoe? The first shoe is going to cost more, right? Because she's less efficient. But as she produces more, she become more efficient. So you're like, you just produced 9. You're like, I'll crank out another 10 because I'm pretty good at it right now, right? So you're better at producing more as you move along. So it maybe cost you, say, $80 to produce that first pair of shoe. But then by the time you're at your 10th pair of shoe, it's only cost you $40 because you're paying yourself as well. Then by the time you get to like your 100 pair of shoe, maybe it's only cost you $15 a pair of shoe. See what I'm saying? But what costs more as a whole, producing 1 or producing 100? Producing 100, but you're more efficient. So that's the rate. That's the derivative. Her derivative is better when she's producing 100. But the cost is definitely more. So the cost function is c of x. We say the marginal cost function is c prime of x. It approximates the cost of producing the x plus 1 or next pair. Company produces X number of shoes. The cost can be estimated by the following function. Cost is equal to 10,000 plus 5x plus 0.01 x squared. What is the marginal cost function? How do I determine the marginal cost function? I take the derivative. C prime of x is equal to 5 plus. That was pretty easy, wasn't it? What is C prime of 500? What would we do to produce C prime of 500? Plug in 500. 5 plus 0.02 times 500. And I get 15. Interpret what C prime of 500 means. So you tell me if I'm right or wrong. The cost of producing 500 shoes is $15. No. The cost of producing the 500 first pair of shoes is approximately $15. The cost of producing the 500 first pair of shoes, so the 500 first pair, the next one, is approximately $15. Yeah, so maybe it costs $80 to produce the first one, $78 to produce the second one, but now the rate is so good, it's only costing $15 a pair right now. So what does C prime of 500 mean? The cost to produce the 500 first pair is approximately $15. So the last thing we're going to do is we're actually going to compare C prime of 500 to the cost of producing the 500 first pair. And that's easy to do, okay? So if it costs me $1,000 to produce 500 pair of shoes and $1,002 to produce 501 pair of shoes, how much did it actually cost to produce that last pair? $2, right? So what I do is C prime of 500 is equal to $15. We know that. But the actual cost of producing the 500 first item is the cost of producing the 501 items minus the cost of producing 500 items. That's what you did. So that's the actual. The derivative is an approximation. So I can figure that out by simply plugging 500 into my original function, right? So that's the last thing we'll do. I'm going to try to make life easier on myself, and I'm going to go into y equals and type in 10,000 plus 5x plus 0.01 x squared. Where do you think I'm going now? My table, which is totally legit on your AP exam for about half of it. Okay, I delete, 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 and I'm going 501, and I'm going 500. Now, I want to be clear that as you look at this, okay, it only shows a certain number of digits. As you go over to it, you can see in Y1 below, that's where it shows the entire number. Do you see that? So it's 15,015.01 to produce 501 pairs of shoes, and to produce 500 is equal to 15,000. So if you subtract those, you get $15.01. So is the derivative a good estimate? It's a really good estimate. And which one's easier to compute, the derivative or the actual cost? I think the derivative is easy to find in that situation. So in economics, we like to find derivatives as well. It's an easy example. That's going to finish off that worksheet. You will not have a new assignment tomorrow, but do be ready because tomorrow I'm excited. It is one of my favorite lessons of the year. I find it super interesting. So even if you're not excited for it, appease me and act like you are. You just gave Sam the look like I was a nutso. You gave Sam the look like I was nuts. Yep. Yeah, exactly. Exactly. All right.